All right, good morning. Today is Tuesday, April 19th. KAP. We did not have homework over the weekend, but hopefully we still learned our practice. Right, we saw the equation to find the missing angle measure, then classify the triangle by its sides and by its angles. Okay, volunteer for the equation. What would that equation look like, Saki? Okay, she added up all the angles in class we learned on Thursday, that all the angles add up to 180. Does it have to be in that order? No, okay, but basically so. Okay, when you solve for it, thank you, Saki. When you solve for it, what do you get for the value of that angle, Andrew? 28. Did y'all get 28? Okay, very good. And then class time. Remember, we can classify it by its sides. Are any of those sides the same? No, therefore it's going to be scalene. Very good. And then the angles. Every triangle has at least two acute. So you covered that up. So this one's 40, this one's 28. Cover up the acute angles, and then the last remains it. So that last angle is very good. Any questions on that? Okay. In my class, we're about to pass back a whole bunch of stuff, so I'm going to pause the video, and then we'll get into it. All right, so what we're going to continue to talk about today is more triangles. We sort of explored some cool relationships about them, how a triangle, all three angles always add up to 180, and then we're going to dive deeper into those different things, okay? So another really cool thing that sort of makes sense when you think about it, maybe you don't like say, oh, I know this fact right off the bat, but once I tell you, you're going to be like, oh yeah, that makes sense, okay? So we have a triangle here, beautiful, amazing, gorgeous, never been better. We typically will name a triangle with 3 letters because we'll give the 3 points for 3 letters. So we might call this triangle ABC because it's side A, B, and C. Y'all good with that? Okay? So typically we will call this like angle A, this is top one is angle B, and this is angle C. Are y'all good with that? Remember how on last week I said like angle, that symbol means angle A, angle B, angle C. Y'all good with that? Okay. So we're also going to be talking about not just the angles but the side today. So we have triangle ABC here as given, and we're going to talk about the relationships between angles and the side that they control. So I always think of it like a movie projector. Okay, how many of us have been to the movie theater before at some point in our life? Okay, those of y'all with your hands down are lying to my face. Okay, so as we know, when we go into the movie theater, there's this massive screen at the front, right? And then if you're a cool kid or you try and be a cool kid, you go all the way to the tippy top and you see that screen in the back of the theater. It's really tiny, and that's where the movie's actually coming from, right? It's this tiny little thing. It's this tiny little point on this side that controls this massive screen over here. Yes? Okay? So that actually relates to a triangle, believe it or not. You're like, because this tiny little thing controls the screen. Wow. You saw it, you see it, okay? And then people will try and go up here and they'll try and do the little finger puppets across the screen because they're #cool kids. But that's pretty much what we're going to be looking at today. Give me one second. All right, so tying that in with triangles, we can say that each of these angles controls a different side of the triangle. So if I'm starting with angle A right here, it controls the side that is going to be across from it. Okay, we sort of imagine this is my little projector, and it's going to control the side that is across from it. So angle A controls side BC. Do y'all see that? So depending on how big or small that angle is, will determine how long the side across from it is. Okay? So we can say that since angle A controls that side across from it, we can give this side over here 2 names. Okay? We can either call it side A because it's controlled by angle A. Okay, if we're just using one letter, that would be side A. And if we gave it 2 letters, we can give it the 2 endpoints. We could also say side BC. And y'all see how that controls because it's the endpoints of that side. Y'all good with that? Okay, so those are either of the names. Looking at side B, at angle B, Okay, using this format, the two letters, what side does angle B control? Side AC. Okay, it's going to control the one across from it. Okay, so again, you can either call this side B or side AC. Could I call it CA? Yes. Okay, but typically we do alphabetical order. Okay, and lastly, angle C is going to control side AB. Okay, it's going to go across. Side AC, no, AB, or side C. Okay, it's sort of flexible because it's just depending on how you see it. You could see it either way. I think typically we use two letters, but again, either way. Okay, so we're going to use that knowledge, how an angle controls the side opposite. We're going to use that in our lesson today.
That's CB.
I'm going to let you read it on your own. Okay, so first we're going to talk about isosceles triangles. Isosceles means what again? Two sides are the same, two sides are congruent. Love that language, that vocabulary. Okay, so in an isosceles triangle, there's a special relationship. The angles across from the two congruent, sides, those angles are going to be congruent. Okay, so let's break that down. If I call this triangle X, Y, and Z, what two sides do you think are going to be congruent? Side YZ and side XY. Those are the two congruent sides. If you remember from last week, we used tick marks to show those congruents. I would agree with those statements, okay? A lot of times we don't want to just assume those are equal sides, but if I'm telling you that's an isosceles, hopefully you can tell that those are the two equal sides, okay? So what this says is in this isosceles triangle, the angles across from those two congruent sides, okay? Those angles, so what angle, let's first look at YZ. What angle is controlling this side? Angle X, very good. The angle across from it, that angle right there, and then what angle is controlling this side? Angle Z. It says, again, in the isosceles triangle, the angles across, so angle X and angle Z, because the sides across are congruent, those angles are going to be congruent. And does that make sense? Okay. Why does it not make sense?
So those two sides, they're congruent.
Okay. Again, if depending because the amount that the angle is big or small, if those are the same, that means the sides across that they're controlling will also be the same. Okay. So again, those tick marks means that they're congruent. I'm just going to say that the measure of angle X is equal to the measure of angle Z. I'm going to make that statement. That's basically what it's saying. Again, if you want to like translate this because you're like, remember if I was saying this out loud, this right here, that's the measure of angle X is equal to the measure of angle Z. Okay. You can also say that the side length of XY is equal to the side length of X. Is that anything too crazy? Hopefully not. Okay. So we're going to use that information to solve different kinds of problems. Let's look at some together. I'll do the fun ones with y'all. By fun, I mean the fraction ones. So let's do this one together. Okay. It says, how can we solve to find Y and finding X? So let's do one at a time. When I'm looking for Y, do you see Y talking about a side length or an angle measure? Okay, I see Y is up here. Is that a side length or an angle measure? Side length. It's on the outside. Okay, so that side length. What do we know about that side length? What's given in that problem? It's a fraction. Okay, what else do we know? What kind of triangle is this? It's an isosceles triangle. I know that this side, HG, is congruent to side KG, GK, whatever you want to call it. Those two sides are congruent. Congruent means that they are the same. They are equal. So it's saying that this right here is equal to this right here. equal, that just means equal, right? So I could write that y plus 2/3, that side, is equal to the other side, 4 3/4. Is that a true statement? Yeah. If I wanted to solve for y, what would I need to do? Subtract 2/3 from both sides. Bada bing, bada boom. Minus 2/3, minus 2/3. This cancels out. I'm left with y. Oh, Miss Lytle, what did she do? Look what she made me do. Fractions. Can I subtract them as they are? No, figure it out then. Okay, wait a second. All right, so in order to subtract these two fractions, I need common denominator. What's the common denominator for both of them? 12. Okay, so that's going to be 4 and how many 12s? 9 12s, and then it's just going to be 8 12s. Okay, subtract them. 9 minus 8 gives me 1 12, and then 4. Okay, still good with that? Okay, it's the same stuff that we've been doing, just makes it spicy. All right, so we have solved for y. Now we're going to solve for x. X is talking about a side length or an angle measure because it's on the inside. Very good. Now, it doesn't tell me anything about those two angles, but we just talked about how the angles across from those two congruent sides, those angles are also going to be equal. So this one over here, this side, is equal to this one over here. So what can I write as my equation? 12x equals 72. How do I solve for x? Ready, set, go. My answer is 6. Are we understanding that concept? Okay. Does that mean that the angle measure is equal to 6? No. It just means that x is 6. Okay. Could I now solve, if Miss Lytle wanted to make it spicy, could I also solve for angle and c? Yeah. If I really wanted to, but okay. Yes, ma'am. Why do we say those are equal? Again, so we said in this triangle, I noticed that is isosceles, meaning that side is equal to that side. We just talked about how the angles that control those sides, so this side is controlled by the angle across from it, this one right here, angle H, okay? And then the angle that's opposite this side, so 72. Because those side lengths are the same, the angles are also going to be the same. They are equal, okay? All right, what I want y'all to do is try number 1 on your own. It should be easier because y'all are more comfortable with decimals, right? So, all right, talk about y. Is y talking about a side or an angle? A side length, very good. Talking about this outside. Those two sides are equal because they are marked with tick marks. Y minus 1.7 is equal to 6.8. To get y by itself, I need to add 1.7 to both sides to make it balanced. Cross that out. I get 8.5. Gucci. Okay, talking about x. Okay, x is talking about that angle measure. I know that 7x is equal to 35 because those are across from each other. 35 is equal to 7x. 3 divided by 7. X is equal to what, Will? 3. No, x is equal to, thank you so much. Awesome job. Okay, so that is talking about isosceles triangles. We're going to also explore equilateral. Equilateral means all sides are the same. You can break down that word. Equal means equal, lateral means side. Okay, this little bit, it should be at the top of your page. Mine's at the bottom, but it's the same links and all that kind of stuff. So it says in an equilateral triangle, all 3 angles are, we just said, the same. What's another math word for the same? Equal. Another one. Equal. Another word. Okay. Yes. Congruent means equal. Thank you. Thank you. Okay, we like spicy words because we're spicy math. In an equilateral triangle, all 3 angles are congruent and all measure what? We sort of explored this last week. If they're all the same, if all the sides are the same, we said that means that all the angles are the same, right? We said that if all the side lengths are the same, that means those angles across from each one, they're all gonna be the same as well, okay, because they open about the same amount. And we said that if we had all three angles, they always add up to 180. So if I have x plus x plus x, we said that equals 180. Copy this down. Okay, maybe you forgot it from last week, so we're refreshing. What's another way of writing x plus x plus x? 3x is equal to 180. To solve for x, we divide both sides by 3. X is equal to 63. Now, is this always true, sometimes true? What do y'all think? For an equilateral triangle, they will always equal 60?
No. Yes.
Okay, so let's test that. Okay, so what if I did 59, 61, and 60? Does that add up to 180? It does add up to 180, but if there's different angle measures, are the sides going to be the same length? No. So would it be equilateral? No. Okay. What if I did 50 and 50 and 50? It doesn't equal 180. So yes, the angles are the same, but it doesn't make a triangle. Thank you so much. Okay. So is that sometimes always what? It is always going to be 60 degrees for an equilateral triangle. Always. Okay, that means it's always going to be classified as what as well? It's always going to be equilateral and acute. So always. Acute. Okay, so equilateral triangles can also be called, y'all ready? This is an even spicier word. Okay, not just equilateral, but they can be called equiangular. Okay. Break it down. Equal, angular. Equal angle. Equiangular. Y'all will probably never see that word ever again in your life until geometry, but you know, it's out there. Yes.
Hey, what's the one word for like a rectangular prism? That's like really, really long.
No idea. I'm trying to think. A rectangular prism?
No, that's not it. That's two words.
Okay, I don't know. We're in the middle of science right now. Okay, so are we good with those facts? Are we good with those facts?
Yes.
Okay, very good. So we can use that information. We can use this right? Solve equations, determine the values of unknown. Do y'all want me? Which one do y'all want me to do with y'all?
Neither.
The second one, because y'all looked ahead and y'all keep those pretty numbers.
Yes.
Okay. So it says first let's solve for y. So ask yourself, is y talking about a side or an angle? A side length. Okay. Because this is equilateral, that means all sides are the same, meaning that this is equal to this. So I can write that 3 1/3 is equal to y plus 1 1/2. Okay, Heyman, to get y by itself, I need to very good. Subtract 1 1/2 from both sides. Class, can I subtract them as they are?
No.
Of course not. That would be easy.
We like easy.
Okay, ready, set, go. Do some math. All right, what's that common denominator? What's that common denominator? 6. So it's 3 and 2, 6, and then 1 and 3, 6.
Yeah.
Correct? Okay, when I subtract, can I take 2 minus 3? No. Okay, so this is, we're going to do that fancy math, if y'all remember. I'm going to regroup. This is going to become 2 wholes, and then I'm going to add the 6 to the 2. So that's going to give me 8. 8 minus 3 is 5, 6, and then 2 minus 1 gives me 1. 1 and 5, 6. Okay, again, you can regroup. We had to do regrouping with fractions. Pause. You add the denominator to that numerator because you're taking a whole one and you're splitting it into the pieces, but it's still a whole. Okay, so I took one of those wholes, made it into the 6 pieces, and added it to the 2 that were there. That way I could take away the 3. All right, now we're solving for x. X is talking about a side or an angle.
Angle.
Angle. Uh-oh. They didn't give me any other angle measures. What do I do? Carolyn, what do I do? Why do you know that? Very good. She just said it's an equilateral triangle. Do you agree with that?
Yes.
Okay, we just discovered that always in an equilateral triangle, the angle measures are always 60 degrees.
So now we figure out how to get put that number into 6.
Yeah, and so Michael, what do I need to write to solve for it?
The line with the equal number
Okay, equal, got it,
and 1.6x
is equal to,
6.
okay, class, what do I need to do to get x by itself? Divide by 1.6. Ready, set, go. No. Okay. Can I divide those numbers? Can I divide them as they are? No. I need to do what? Multiply by 10, move that decimal one spot each. There's no number. What do I do? Add a 0. Okay. I know there's a lot of laughter going on right now. Cut it out. Okay. Does 16 go into 6?
Yes.
No, it does not, but it goes into 60
It does. That's
3 times to get me 48. When I subtract, I'm left with 12 at the 0. 16 goes into 120. 7 times. 16 times 7. That's 2. That's 4. That's 112. Okay, I'm left with 8. Added 0. Still going. Goes in 5 times. What does it give me? 80 exactly. Okay, y'all should have been working that on your own. That's why I'm going this quickly. Okay, but x is equal to 37.5. Okay, go ahead, do that other side. If you finish that, we'll check over that last one. But then you can start on the evens of the partner practice. Okay, pause and play when you're ready to check that out. Real quick, because my class has pointed it out, 2 people have now pointed it out. Just to clarify, this M, like in this problem, that's talking about meters. Over here, by V, it's talking about yards, because we're talking about lengths of things, side lengths. They usually have units. It's not variables, it's just measurement. Clarify. All right, for these last two, solving for y. Y is talking about a side length, so 25.62 is equal to 6.1 y. Divide both sides by 6.1. What do y'all get for y? What was that? 4.2. Awesome. For x, x is talking about an angle. What do we know about the angles in equilateral? 60 is equal to 4x. Divide by 4. Divide by 4. X is equal to 15. All right, so you should have been working on the evens for homework. You can check those on your own, and then the homework is going to be odds tonight. Please make sure you're working on those problems. Yes, ma'am? If you did not finish the evens, they are now extra practice. Thank you and good night. Good night.